Here is 5.5, part 2. There's a definition here of complex numbers in the box. Please go ahead and write that down. The A represents the real part, and then the BI represents the imaginary part. I do want you to make a note of this in your notebook. When you have an I squared, you replace that I squared with a -1. And then below this, I'm going to show you why you don't need to write that example down. Here's the reason why. When you have an I times an I, it would be I squared. But I'm going to just replace those i's back with what we started with, is negative square root of 1 and negative square root of 1. The rules with radicals is if you have two like radicals, you can combine them back together, -1 and -1. And now they're just one radical. And then I have -1 squared. Now remember, a square root and a squared undo each other. So then you're left with -1. So that's just kind of the reason why. But for us in our class, if you see an I squared, just replace it with a -1. All right, the next thing is called complex conjugates. When you have a complex conjugate, you have A plus BI. Its conjugate is A minus BI. Notice the signs. This is a plus and this is a minus. So here are some examples below. I'd say probably write these down. Write the complex conjugates of the following. We have 3 minus 5i. It's asking us for the complex conjugate. So what you do is you change the sign of the imaginary part. So its example is going to be 3 plus 5i. Example B, -4 plus 6i. The conjugate would be -4 minus 6i. Notice this is a negative, this is a positive. This example is a plus, minus. Last example, question C, 5i. The real part is gone, so you only have the imaginary 5i. So we just change the sign from a positive 5i to a negative 5i. And that's how you do complex conjugates. The last thing is an example where we equate two complex numbers by finding the values of x, such that it makes this equation true. So remember equations. Equations are things on the right side are equal to the things on the left side. So if I have 4x plus 10i equals -10 minus 4i, I have the real parts, which are right here, and then I have the imaginary parts, right there. So how you solve this equation is you set the real parts equal to each other and the imaginary parts equal to each other. So from this, just go ahead and write down this bottom part. So we equate the real parts, which is your 4x equals 2, and then you equate the imaginary parts, which is 10I equals negative 4I. And then you just solve for their variables. So in this first example on the left, 4x equals 2, to solve for x, you divide both sides by 4. So you get x equals 1/2. Then over here, you want to solve for y. So right now I have 10I equals negative 4I y. What I need to remove is the negative 4I. So I divide both sides by negative 4I and negative 4I. And then I reduce that. The negative 4I and the negative 4I cancel. And then the i's cancel on the left, and you're left with negative 5/2. So your two solutions, the x equals 1/2 and the y equals negative 5/2. And that's how you solve for making this equation true. Here will be the assignment for 5.5, page 353, 1 through 21, and then 28 and 29.